Finally, we can use dlsim and implicitly dlopen to cause the malloc that we end up embedding in our program to refer to the malloc that comes from libc. So instead of using dlopen with libc, this example code uses just rtld next. I have to define GNU source to get that particular shortcut, but that just means look for the symbol malloc starting after the one that would be found first. Find the second one, and so on. Right, start looking in the chain of libraries after the main executable. Right. So we get that malloc pointer, and similarly we get the free pointer. And if we do this, then we have just functions malloc and free. Int.c refers to malloc and free, and so we could just link them together like this. Int and rmalloc, and since rmalloc uses dlsim, it needs ldl. So double check that I got this right. Here's rmalloc. Okay, and so we can link together int.c with rmalloc and dynamic linker, and there we go. We interposed on the malloc calls an integer. But we're still playing a kind of linker game here. We're sort of halfway solving the problem of linking and halfway solving the problem with runtime DLL stuff. It would be neat if, suppose I do gcc int.c and I've got the final executable. I've got the one that does not print out anything, and that if we disassemble it refers to malloc and free. But remember that a.out is referring to malloc and free through the dynamic library libc.so. And I could take my implementation of rmalloc and I could compile that to a shared library that also provides malloc and free. I just need to compile with shared and fpic rmalloc.c, and let's make it rmalloc.so. Okay, so we have rmalloc.so. That is similar to an executable. It's referring to libc, but if I try to use malloc in here, it's the malloc of rmalloc. Right. So then what I'm going to do is exploit the fact that this int is really dynamically linked to libc. The resolution, the linking of malloc to libc doesn't happen until runtime, when that libc.so is resolved, and I can set the ld preload environment variable to rmalloc.so, and that says load rmalloc.so before resolving other libraries for the executable, even before resolving libc. And if I run a.out in that situation, then it's because when I linked a shared object, I forgot to link it to DL. So now when I run it, it'll work. Okay, why did I have to do this? Why didn't it give me a warning before? Because a shared object can still have unresolved things, and when it gets preloaded, that's when it has to get resolved, and it didn't know where to look. There was nothing already in the environment. Anyway, going back to the intended lesson here, this ld preload environment variable is kind of like ld library path. It communicates to the system that you want to search in this shared object, rmalloc.so, before searching anywhere else, and so the malloc and free that are there will get picked up. One more thing I didn't show before. Suppose you want to know what rmalloc provides, then it's the nm tool that will show you. So you have to spell the file name correctly, but if I say nm rmalloc, then we see it has all of these symbols that are relevant, but in particular tmalloc means that it provides the malloc function, and tfree means it provides the free function. And if I do nm on a.out, then we'll see that it provides the main function, but it has a reference to malloc, and it also has a reference to free.